All right, we're going to learn about how to create graphics-based animations using JavaFX and a special class called the AnimationTimer class. To begin, we're going to start with a basic template file which has all the imports we already need added to it. In this class, it's called Animation Examples, and it's going to extend the basic application class in JavaFX. The standard public static void main for such a program. We're going to try to launch the application. If there's an exception, we'll catch it. And then finally, when the program is over, we'll exit. Since we're extending the application class, we need to have a start method. And the start method requires a stage object as a parameter. We call that main stage. It's always a nice touch to set a title for that stage. So this is called Animation Examples. And I also always like to use some kind of a layout manager. I'm a big fan of using a border pane that divides your window into 5 well-defined areas: the top, bottom, left, right, and center. It's exceptionally good when you're using a menu bar, even though we won't in this example. And then once you've got your layout manager selected, you're ready to set the scene. We pass in our border pane as a parameter, and then we connect the scene to the stage. Then I'll write some customized code in here. Then when we're all done, we have to always remember to show the stage to get the application running. All right, to begin, I'm going to go ahead and create a canvas object on which we can display graphics. So I'll say canvas is a new canvas object. And I'll make this perhaps 600 by 600 pixels. In order to render something to the canvas, we use another object called a graphics context object. We'll call that context. And we get that directly from the canvas object. So autocomplete this. This should be get graphics context 2D. Then we always have to remember to attach any object we actually want to see, attach that to our window in some way. So I'll set this to be the center of our border pane object. Let's say root.set center to be this canvas. And finally, we're going to need an animation timer object. It's a wonderfully useful class. It runs its code 60 times a second, which is great for animation. So I'm going to create a new animation timer object. I'll call it timer. It's new animation timer. Now, this is like an interface, so we're going to create an anonymous inner instance of it, but this won't compile until we create the necessary method, public void handle. This takes as a parameter a long integer, which has time in nanoseconds. Even though we honestly won't use that at all, we still have to specify it. And within this, we could create some kind of drawing operation on our canvas. And so what I'd like to do is maybe I'll draw a small blue dot moving across the screen, for example. And so I'll create 2 variables. I'm going to go ahead and declare them at the class level here. So let's say I have a double X and a double Y. In the start method, I'll go ahead and initialize those variables. Let's let X equal 0 and Y equal 0. That corresponds to the top left corner of the screen. And then within the handle method, now let's see, I want to draw a blue dot. Maybe it's going to move across the screen, maybe horizontally faster than vertically. Let's say X plus equals 2 and Y plus equals 1. And then I'd like to draw, say, a blue dot. Let's do context dot, maybe I'll set the color, fill to a color dot blue. And then I'll say context dot I want a filled in oval. First, I need to say its X and Y positions, and then the width and height. Let's make this fairly large, maybe 25 by 25. All right. And then once you set up your animation timer object, it won't actually start until you call the start method. So I need one more line of code down here at the bottom, timer.start. All right, once that's all done, I should be able to give this a run. So right click, run the main method, and sure enough, there goes my dot. And notice how it appears to be smearing out into a line. That's actually to be expected. One thing that we didn't do is actually clear out the canvas and overwrite what was there before. So what I'm going to do next is, before drawing that blue dot, first we'll clear the screen. Let's start adding in some comments as well. So these two lines of code, they draw a dot on the screen, on the canvas. This is going to move position along a line. And I also want to add in two lines of code that clear the canvas before we redraw to it. Let me say context. Let's set the fill color to be color.white. And then let's also create a rectangle which covers the entire canvas. So context.fillRect. Starting at 0, 0 in the top left corner. Our canvas is 600 by 600. With that change made, we should see a moving blue dot. All right, let's go ahead and run. And sure enough, there goes our blue dot. All right, for our next animation example, I'd like to change the pattern of movement. In this example, it moved in a straight line. Next, I'd like to have the dot move around in a circular pattern. And in this case, and many others, it's often simpler to write the positions of X and Y as a function of time. So I'm going to introduce a new variable called t to keep track of how much time has elapsed since the application began running. I'll begin by creating a new double variable at the class level called t. Then the start method, I'll go ahead and initialize that. Say t equals 0. And then the handle method, it gets called 60 times a second. So I'm going to increment the time variable by saying t plus equals 1/60th of a second. Now be careful here. If I just type 1 divided by 60, it defaults to integer division, which should be 0. So I want to make sure I type 60.0. So I'll increment time. I'm going to comment out these two lines of code where the position moves along a line. And instead, I'm going to move the position along a circle. In this case, I'd say, for instance, x equals cosine of t, and y equals sine of t. Right? Those are the parametric equations of a circle. However, that gives you a circle centered at the origin of radius 1. And in computer graphics, that's in terms of pixels. So that would give you a 1 pixel wide circle. You wouldn't be able to see much movement at all. So what I'd like to do here is increase the radius of the circle. I'd like to scale it up. I'd like to multiply it by some factor. So I'm going to multiply the sine and the cosine by 200. And so this would move the position along a circle of radius 200. That's going to be a little bit more interesting to look at. The final thing I'd really like to do, though, is I'd also like to shift the center of this circle that the dot's moving around. Right now, the circle, by default, is centered at 0, 0. Right? So we're only going to be able to see a small portion of the path of the dot, because 0, 0 is in the top left corner of the canvas. So to shift it, I'd also like to add some constants here. Since my canvas is 600 by 600, I'm going to add 300 to each of these. So I'll have a circle of radius 200, centered, not cantered, but centered at 300, 300. And that'll be a lot more interesting to look at. So I'll go ahead and recompile that and give this a run. If everything goes according to plan, we should see a blue dot moving in a circular path. Go ahead and run the main function. And sure enough, there's our circle moving in a circle, our blue dot moving along a circular path. Excellent. So far, so good. The next thing I'd like to do is show you that not only are we able to change position over time, we can change anything we want. For example, we could change the color over time as well. Right? We could make the color a function of t. Right? Instead of, for instance, always using color blue, I'm going to go ahead and change the fill color over time by defining a new color C. Now there's a few ways you can define a color in JavaFX. You can create a new color, and then you can give it some values, red, green, blue, and alpha. But I'd really like to have it cycle through the rainbow. And it's more natural to think of colors in that way in terms of three values called hue, saturation, and brightness. To create a color in this way, I need to use a static method in the color class, color.hsb, where I can type in, well, color, saturation, and brightness. So for instance, hue is a number which goes from 0 to 360. And think of that as a number in degrees as you move around a color wheel. When the hue is 0, that gives you the color red. As you go up to 120, that cycles through the colors from red through to green. 240 is blue. And then when you get back to 360, that brings you back to red again. So for instance, the green family of colors is around 120 for hue. Saturation and brightness, think of saturation as vibrancy on a scale from 0 to 1. 0 would be a washed out gray light color. I like to use 1 for saturation. That gives us a very vibrant color, let's say. And for the brightness, that's another variable that goes from 0 to 1. 0 would give you a black color, but like a nice bright green. So for example, I could change the color in this way. And this would change my circle to be a bright green circle. Let's go ahead and give this a run just to see how that looks. And there's our traveling green circle. But the point, if you recall, is to have the color of the circle change over time. So instead of this, I'm going to say create a new variable called hue. So double hue. I'm going to make that, let's say, if we just set that equal to t, for example, that means that it's going to go from 0 to 360 over the course of 360 seconds. It means 6 minutes to go through a complete color cycle change. That's pretty slow. I'm going to speed it up by a factor of 100. I'm going to use that in place of the hue value. So that means we should see this dot cycle through the color spectrum over the course of a little over 3.5 seconds. Let's go ahead and compile and give this another run. There we go. It's green, it's blue, magenta, red, yellow, green, cyan, blue, magenta, red, just going right through the spectrum there. I might actually slow that down a little bit so we can appreciate all the intermediate colors more fully. But there you go. You've got a color changing circle over time. And another thing we could do while we're at it, while we're slowing down the progression of the colors a bit, maybe I'll make that 60 instead. We could, for a very neat effect, we could choose to not clear the canvas. This time we'll actually see all the colors preserved because we're not clearing out the circle like we did before. All right, so again, this program is going to continue to draw circles overlapping each other around the path of a circle, but we'll also see the circle change color over time. This should be a pretty neat effect. Let's go ahead and give this a run. See, red to orange to yellow, green, cyan, blue, magenta, and back to red. So we're kind of seeing it trace out a circular pattern there. That's pretty fun. Now, for one more bit of fun, what I'd like to do is instead of having it go in the path of a regular circle, I'd like to give it the freedom to move around a little bit more randomly. And so these equations for x and y, right, this gives you a nice perfect circle. What I'd like to do is change the period of x and y. So maybe, for instance, I'll say x is equal to 200 times the cosine of 1.337 times t. And let's say I need to multiply by another randomish number here, so maybe 3.456 times t. And so we're still going to see some periodic motion. The ends aren't going to join up in a perfect circle like they did before. But again, this should be a pretty neat effect. Let's go ahead and compile and give this a run, see how it looks. And there we go. Right, we see the same color changing as before. You can see that x and y are periodic. But in this case, you get to see more of the colors spread out over time. So that looks pretty cool. All right. The next thing I'd like to do is I'd like to change this. Instead of drawing colorful circles on a canvas, I'd like to draw maybe a bouncing ball, an image of a bouncing ball on kind of a grassy background. Right, so instead of doing this kind of animation, I'd like to do something else. So for this, you're going to need a couple of files. I have an images directory and I have a picture of some grass and a basketball. What I'd like to draw is show you how to create a bouncing basketball on the grass kind of effect. All right, so I'm going to go back to the code. And I'm going to comment out this code that I used before. I still want to increment time, but this time, let's see, let me do a nice big comment here. And now I'm going to go ahead and create two images. And so create two image objects. One of them is going to be, let's say, an image called grass. That'll be a new image. In my images directory, I have a file called grass.jpg. And I'd like this image to be scaled to 600 pixels by 600 pixels. And I would like to, I don't really care about preserving the aspect ratio, but I do want smooth scaling. So those Booleans control those aspects of the picture. And I'll also create an image called ball. Again, a new image file. The images directory, there's a file called basketball.png. Now this is a PNG file because PNG support transparency. I want to make this one a little bit smaller, 100 by 100. And in this case, I'll preserve the aspect ratio and use smooth scaling. Right. So I've got an image of grass and an image of the ball. And it turns out that the context object also has methods which will allow me to render images directly onto a canvas. So for example, I can write in my handle function context.drawImage, like to draw the image of the grass first. This is going to take up the whole canvas, so I want to center that at 0, 0. And then next, I'd like to draw another image, this time the ball. I'd like that to be kind of centered on the screen. So I also have to take into account how large the ball image is itself. But that should look pretty good. Now if we go ahead and run this example, we won't see anything move yet because we're drawing these at constant coordinates. Let me go ahead and run the main method, and we should see a nice grassy background. and a ball, which kind of looks like it's floating. All right, next I'm going to use a mathematical formula to get this ball to bounce up and down. And once again, the trigonometric functions, sine and cosine, are here to save the day. To bounce up and down, vertical motion is controlled by the y coordinate. So I'm going to shut down that example. And instead, I'm going to say, let's say y equals, I could do math.sine of t, but remember that only gives me 1 pixel of motion. For a little bit more, maybe I'll say 200 times sine of t. I like that to be a relatively fast bounce. The period of sine is 2 pi. That's a little over 6 seconds. So maybe I'll say 4 times t. I'll use that in place of this. And again, one thing I always want to remember is where's the centered at? This would start at 0 as its origin, and it would go up and down by 200 pixels. I want to shift it towards the center of the screen. So maybe I'll add 300 to that. Right, and this will cause the ball to appear as though it's moving up and down in kind of a periodic pattern. Let's compile this and give it a run. And sure enough, we have a ball bouncing up and down. Now, one thing which doesn't look too great yet is it looks okay at the top of its path, but as it gets close to the bottom, it appears to slow down. Right, the ball slows down at the top and the bottom of the path because that's the way a sine function looks. It's nice and smooth at both the top and the bottom of its path. So I'd like to make this look a little bit more realistic. So what I'll do here, also going to slow down the bounce just a little bit. That was rather fast. So I'll just make the time go twice as fast. Instead of using math.sine by itself, I'll also do the absolute value of the sine function. Right, so this will actually cause an abrupt change when it goes from positive to negative. And if you had some kind of a graphing calculator, try graphing sine of x and then absolute value of sine of x, and you'll see kind of what I mean. So what this will do is it will add 200 times a positive number to 300. One thing which is going to look a little bit strange is since I'm adding to 300, remember in computer graphics, the y increases as you move down on the screen. Right, so this would cause the ball to appear to bounce only in a downwards direction. Here, let me show you what I mean. We go ahead and run. Right, so it appears to be bouncing kind of off the sky a little bit, which is a little bit funny. It's like it bounces off the sky and then it like hovers in the grass a little bit. That's basically backwards. So what we're going to do instead is we're going to put a negative in front of that. Right, so the negative means starting off at 300, right, the absolute value of sine that generates a number from 0 to 1. Multiplying that by negative 200 means it'll subtract from the y, moving it up on the screen in that range. All right, recompile. And let's go ahead and run this one more time. If everything goes according to plan, yep, we've got a nice bouncy basketball bouncing in a field forever and forever. Don't know why it's bouncing, but the important thing is we are able to generate an example of a graphics-based animation using JavaFX.